So after introducing tan, sec, cosec and cot, the next step is learning how to differentiate them. Now, you actually know everything you need to know to be able to do that so far, to the point where I actually got you to do that secretly as one of your questions the other day. So I'll point that out when we come to it. So tan x, if you want to differentiate it, you've got to think, well, what is tan x? Tan x is equal to sine x over cos x. So we need to differentiate sine x over cos x. So that would be an example where you need the quotient rule. So if you look, you might recognise this from the work the other day. So if we say that u is equal to sine x, u dash would be cos x, v is equal to cos x, v dash is equal to minus sine x. That would mean that if we put it into the formula, u dash v, so cos x times cos x minus uv dash, so you have sine x times minus sine x. That is, well actually I've got to put my v squared on the bottom first, over cos x squared. That is equal to cos x, or cos squared x, minus minus is a plus, so plus sine squared x over cos squared x. And cos squared plus sine squared, as you know, is 1, so it's 1 over cos squared. Now, when I was writing the answers to your work the other day, that was as far as I went. But you should hopefully know from the video I did yesterday that 1 over cos squared is the same as sec squared. So now we're going to say tan x differentiates to sec squared x. So if you differentiate tan x, that would get you sec squared x. And it also, in a similar way, if you differentiate tan of kx, so it's some amount of x, you would get k sec squared x. So I won't go through the full-blown chain rule on how to do it, but you just multiply by the value of x. Okay. So let's try sec x. So if you remember, sec x is 1 over cos x, or cos x to the minus 1. So since I've just got something in a bracket to a power, I can use the chain rule. So if I differentiate this, now I might have not shown you this notation before, but if you just put d by dx brackets whatever you want to differentiate, that mathematically means the differential of this equals, so if you multiply by the power, lower the power by 1, and then multiply by the differential of what's in the bracket, so you have cos x, that differentiates to minus sine x. So getting a little bit more complex. So minus times a minus is a plus, and that is 1 over cos squared x multiplied by sine x, or sine x over cos squared x. More commonly, you will see that written as, well, you can split it up so you have sine x over cos x, which is tan x, multiplied by 1 over cos x, which is sec. So more commonly, you will see that as the differential of sec is tan x sec x, or sec x tan x. I forget which way around they write it, but it's the same thing either way. And if you differentiate sec of kx, that will just go into a similar thing. You would have k lots of tan kx sec kx. Just notice a slight mistake on what I did before. Tan differential of tan kx should be k lots of sec squared of kx. You've got to remember that it's still sec of, or whatever trig function you have, it still has the same thing on the inside. Right, cosec x, almost the same thing, but this time you have sine x, which is to the -1. What am I doing? Sine x to the -1. So if you use the chain rule, that would get you that the differential of cosec x would be times by the power, lower the power by 1, and multiply by the differential, which is cos x. So that is minus cos x over sine squared x. Again, doesn't look particularly pleasant, but more often than not, you will see this as minus cos x over sine x, which is cot x, multiplied by 1 over sine x, which is cosec x. So they would say that the differential of cosec x is minus cot x cosec x. And showing you a similar thing to what we did before, if it's cosec of kx, you end up with minus k lots of this. Finally, the last one I need to do would be cot. And then we've done them all. So if we have cot x, you need to think of that as 1 over tan x. You could differentiate that using the chain rule. I personally find it more easy to do cos x over sine x and then do the quotient rule. So if u is cos x and u dash is minus sine x, v is sine x and v dash is cos x, then if we put it into the formula, you would have minus sine x multiplied by v, which is sine x, take away cos x multiplied by cos x, all over v squared, so sine x squared. Minus sine x times minus sine x is minus sine squared x, minus cos squared x over sine squared x, which is minus lots of sine squared, add cos squared over sine squared, and then sine squared plus cos squared is 1, so it's minus 1 over sine squared x. Now I went through that quite quickly. If needs be, feel free to slow down the video and go back and just watch the steps. It's all stuff you know so far. Now 1 over sine squared, we said before, was cosec squared x. So the differential of cot x, all the way up there, is minus cosec squared x. And the same thing applies if you have a multiple of cot. So cot of kx is equal to minus k lots of cosec squared kx. Now, all of these are given in the formula book. So if I just write out very quickly the ones that are given in the formula book, they would give you something along these lines where they say, if this is your function, if you have tan kx, they would say your differential would be k sec squared kx. They would say that if you have sec of kx, it's k tan kx sec kx. If you have cosec kx, that is minus k cot kx cosec kx. And if they gave you cot kx, you would have minus k cosec squared kx. So depending on the kind of question, you could use these and just go straight to the answer. But equally, you might have to show it in steps. So it depends on what kind of question that you've given. So they might say, show that the differential of tan kx is k sec squared kx. And you would have to show the steps. But if you were just given a question, say involving the product rule, so let's just make one up. This will not be particularly nice, but I'll just do the one. So if you had y equals tan x cot 2x, and you had to differentiate it, you would have to do what you normally do, where you have the product rule. So you'd say u is one of them, tan x, v is the other one, cot 2x. And if you just refer to your formula book, you could go, well, u dash, well, tan of x is, well, it's 1x, so it's 1 sec squared of 1x. Or tan, it just goes to sec squared. Cot, a bit more complicated. So referring to the formula book, cot of 2x goes to minus 2 cosec squared of 2x. And then we have all the bones of what we need to do. So we could then say dy by dx is u dash v, so sec squared cot 2x, add u v dash, tan x minus 2 cosec squared 2x. And that would be a correct answer. There's things you can do to simplify. I'm not going to go through everything right now because it's not needed. That's for a different video. But that would be how you would do, for example, a product rule involving them. So I want to give you a few questions that are, some of them will be showing that. So try and run through each of these again. That's going to be one of your questions. And then I will just give you some questions where you have to just use the formula book and, well, not the formula book, but this list I've given you here, which is in the formula book, and then find the differentials if it involves a chain rule or the product or the quotient rule. Okay? See you in the next video.